When historians describe the 19th century modernization of Amsterdam, they celebrate what rose above the waterline: expanded canal rings, steam-powered pumping stations, and engineering triumphs that transformed a trading port into a modern European capital. But the quieter story, barely visible in municipal records, began beneath the canals, in layers of infrastructure suggesting an earlier chapter had been quietly overlooked. It began with a routine maintenance directive. Engineers were instructed to dredge accumulated silt, reinforce canal walls, and determine whether Amsterdam's waterways could support heavier industrial traffic. The task was practical and procedural. No one involved in the modernization effort anticipated that draining sections of the canals would expose structures no official record acknowledged. The first anomaly emerged when workers drained a canal segment near the Herengracht for structural reinforcement. Beneath the familiar brick lining, attributed to 17th century construction, crews broke through a layer that had not been exposed since the canals were first engineered. What they expected to find were standard foundation supports and accumulated sediment. Instead, they encountered masonry extending far deeper than any municipal blueprint suggested. The infrastructure did not correspond to Golden Age canal construction. It descended several meters below documented foundation depth. Internal memoranda from the period repeat three understated phrases: pre-existing infrastructure, unexpected depth, and function unknown. These were not words used lightly in Dutch engineering archives. At first, supervisors categorized the discovery as remnants of medieval drainage or abandoned water control works. Amsterdam had, after all, evolved through centuries of land reclamation, but the geometry complicated that explanation. Certain channels displayed gradients too consistent for improvised drainage. Flow regulators were embedded into the walls at intervals suggesting calculated hydraulic distribution rather than waste removal. Survey photographs taken during the dredging process reveal walls cut with striking precision. The stone and brick surfaces appear uniformly smooth, their joints unusually tight. Even accounting for photographic limitations of the 19th century, the tolerances seem beyond typical hand-laid masonry of the 1600s. Some engineers privately noted that the construction looked less like incremental canal building and more like exposure of something older, something already present. In multiple locations, conduits extended laterally beneath the canal bed, vanishing into darkness beyond the excavation zone. These were not minor feeder drains, they were structured passages, consistent in width and alignment. The design did not resemble Dutch Golden Age manuals. It did not resemble medieval hydraulic systems either. One supervisor described the deeper layers as engineering that appeared inherited rather than invented. The phrasing is cautious but revealing. It suggests the impression that later canal builders may have been connecting to something already in place, as though they were adapting rather than initiating. The further crews dredged, the more the canal system began to look less like an isolated 17th century achievement and more like the visible surface of a longer infrastructure sequence. In certain sections, the upper canal lining seemed almost secondary, resting atop masonry that bore signs of earlier planning. If these deeper channels predated documented construction, why were they absent from every official map? If they were part of an earlier phase, why did they align so precisely with later canal geometry? What the modernization effort uncovered was not random debris or forgotten tunnels. It was a coordinated system at depths no maintenance record anticipated. A system that, once revealed, raised questions about whether Amsterdam's canals were constructed or uncovered. As dredging reports accumulated, the tone of documentation shifted noticeably. Early entries were technical and detailed, complete with measurements and sketches. But within months, the language began to narrow. Documentation became cautious. Descriptions that once specified unusual regulators or unexplained depth were replaced with neutral phrases such as earlier waterworks or foundation elements. The shift was subtle but consistent. Language moved from descriptive to defensive. Photographs taken during initial discoveries showed wide-angle perspectives of entire chamber systems. Later images focused narrowly on surface repairs. Some of the deepest layers were omitted entirely from revised engineering summaries. By the late 1800s, several excavation zones were partially refilled, officially for structural stability. Sections marked pre-existing infrastructure were sealed where necessary, stabilized, and returned to darkness. Files referencing the deepest channels were distributed across departments rather than compiled into a comprehensive study. The silence was not dramatic, it was procedural. As dredging expanded beyond isolated canals, survey teams began mapping what lay below with greater discipline. What emerged was not a scatter of odd tunnels, but a pattern of coordination that resisted normal explanations. Amsterdam's canal story is usually told in clean phases: medieval groundwork, Golden Age expansion, then 19th century reinforcement. Different centuries, different builders, different tools. Yet beneath the canal beds, those distinctions blurred. The first anomaly was geometric alignment. Each layer, whether attributed to the 17th century or to the undocumented depths below, followed the same grid orientation, the same directional flow logic, the same spacing between junctions. Different centuries do not build in perfect alignment. Streets drift, measurements change, priorities shift, mistakes accumulate, unless they were all working from the same blueprint, unless the blueprint already existed. In multiple excavation sites, conduits from one period connected directly into channels buried several meters beneath them. These were not accidental intersections, they were continuations. Upper-level feeders entered older trunks at angles that matched, not approximated. Flow regulators positioned in later brickwork mirrored regulator housings embedded below. Even when separated by what appeared to be centuries of sediment, the orientation stayed consistent, unless what we call construction was actually adaptation. Surveyors noted that the deeper channels adhered to the same hydraulic logic as the visible canals above. Curves maintained efficient flow characteristics. Junction chambers repeated the same proportional ratios. Gradients, where measurable, aligned with mathematical consistency across districts. Medieval builders should not have anticipated the geometry of Golden Age canal rings. Golden Age engineers should not have aligned their work so precisely with structures they supposedly never saw, unless those structures were not unseen, unless they were known. Certain sections revealed layered masonry, where later brickwork rested directly atop older stone channels without disrupting alignment. The upper canals did not overwrite the deeper system. They followed it. In several districts, crews traced lower conduits that extended beyond the footprint of documented waterways, implying a network larger than the city's official plans. Different centuries do not replicate identical hydraulic standards by coincidence, unless they are inheriting rather than inventing. And the alignment wasn't only linear. In several junction chambers, surveyors found overflow paths, side returns, and bypasses, repeating the same choices at different depths, like a design rule being obeyed. Different eras should diverge in small decisions, yet the small decisions matched. It raised an uncomfortable thought. Perhaps later builders were not designing freely, but fitting their work to constraints already set below. As mapping continued, engineers observed uniform dimensions recurring at depth. Consistent widths, repeatable arch profiles, standardized junction shapes. This did not resemble improvised drainage. It resembled an engineered vocabulary. Some sealed conduits were packed with sediment so dense that crews initially mistook it for natural clay. Once cleared, interiors appeared surprisingly intact. Walls smooth, joints tight, regulator niches undisturbed. It was as though the system had been covered rather than destroyed. In private notes, one supervisor described the modernization work as less an expansion than an exposure. The deeper layers gave the impression of a system already waiting beneath the city, an older grid that later generations had connected to, reinforced, and gradually obscured. A practical question followed. If medieval Amsterdam encountered fragments of earlier hydraulic works, how would builders have known their citywide orientation? There are no surviving records of comprehensive excavation before canal expansion, no maps admitting a subsurface master plan. And yet, the alignment suggests guidance, unless portions remained accessible long enough to set the lines, unless the deeper infrastructure persisted as an inherited foundation. The implication is not that Amsterdam's engineers lacked skill. It is that their greatest skill may have been integration, adapting what they found, stitching new masonry into older trajectories, treating buried channels as fixed references. If so, the celebrated canal rings become something slightly different, less a beginning, more a continuation. Different builders, different centuries, identical hydraulic logic, unless the foundation was never truly built in the Golden Age. unless it was simply the final layer. As dredging progressed into the deepest layers beneath the canals, the technical inconsistencies became harder to dismiss. These were no longer questions of alignment or mapping. They were questions of capability. Engineers recorded gradients measured with extraordinary precision. In several conduits, elevation changes varied by only millimeters across extended distances. Such tolerances exceeded what simple gravity-fed drainage required. Some channels were shaped with hydrodynamic curvature designed to reduce turbulence, suggesting controlled flow rather than passive runoff. More puzzling were the circular chambers discovered at key junction points. These were not irregular wells or storage pits. They were symmetrical, thick-walled, and internally reinforced. Several contained internal baffling structures, positioned as if to regulate pressure surges. Their geometry resembled pressure-rated vessels rather than open reservoirs. Yet no historical record indicates that Amsterdam operated a pressurized hydraulic system beneath its canals. In certain sectors, lower passages angled upward against expected gravitational logic. Water appeared to have been directed vertically through sealed conduits. Such configurations only make sense in systems managing controlled pressure. These were pressure-rated structures with no recorded pressure system. The interior surfaces of many channels were unusually smooth. Tool marks did not resemble rough chisel work. Instead, they appeared uniform, almost mechanically bored. Tools that officially did not exist at the time would have been required to achieve this consistency across stone and brick. Even more troubling was the integration of metal within the masonry itself. In several excavations, crews uncovered metal elements embedded directly into channel walls. These were not later reinforcements bolted into place. They appeared fused or cast into the original structure. Some joints displayed signs of high-temperature bonding. Metallurgical integration beyond documented capability. Official explanations later attributed these findings to subsequent repairs or undocumented reinforcements. But the metal did not appear retrofitted. It appeared foundational, integrated during initial construction. That level of coordination between stonework and metal framing would have required manufacturing techniques not reflected in Dutch records of the 17th or 18th centuries. Additional anomalies emerged in flow regulators. Some mechanisms incorporated adjustable gate systems that resembled industrial control assemblies more than canal sluices. Their tolerances were tight, their positioning deliberate, their complexity unnecessary for simple water transport. If Amsterdam's canals were built solely for navigation and drainage, why were such sophisticated hydraulic controls present at depths beyond documented construction? Why did certain chambers appear capable of managing pressures far greater than canal traffic demanded? These were not isolated irregularities. They formed a consistent pattern, gradients too exact, surfaces too refined, materials too integrated, mechanisms too advanced, engineering beyond accepted chronology. Yet nowhere in the official modernization reports is there acknowledgement of a pressurized network, a deep hydraulic grid, or a metallurgically integrated substructure. The deeper the survey teams documented, the less the infrastructure resembled incremental canal building, and the more it suggested a system designed for a different purpose entirely. Shortly after the most technically complex discoveries were recorded, a pattern of closure began. Sections containing the deepest conduits were resealed first. Access shafts were reinforced. Junction chambers were backfilled. Official explanations cited structural safety and the need to prevent undermining canal walls during modernization. On the surface, the reasoning was sound. Excavating beneath active waterways carried risk. But the sequence of closures raised quiet concern among some engineers. If this was about safety, the weakest structures would have been sealed first. But that is not what happened. The passages most quickly buried were often the most structurally sound. Precisely cut chambers, pressure-rated conduits, metal-integrated walls that showed little sign of instability. Meanwhile, visibly deteriorated medieval sections remained accessible for documentation and repair. Entire lower corridors were filled with sediment pumped deliberately into spaces that had only recently been cleared. It was not gradual, it was immediate. The official language remained procedural: stabilization, reinforcement, budget constraints. Yet the practical effect was unmistakable. The deepest anomalies, the pressure chambers, the upward flow passages, the integrated metal frameworks, were returned to darkness before comprehensive study could occur. By the late stages of the 19th century modernization, something subtle but unmistakable occurred. The dredging did not conclude in the way major infrastructure projects typically conclude. It was not celebrated as fully surveyed. It was not documented as comprehensively resolved. It was halted. The deeper the crews progressed, the more the tone of their report shifted. Early documentation was confident, procedural, technical. Measurements were recorded, diagrams were drawn, photographs captured wide views of exposed foundations. But toward the end of the project, the language grew guarded. Description shortened. Certain layers were referenced only indirectly. Documentation became cautious. Entire sections of the deepest network were summarized with indefinite phrases. Earlier works, substructure, non-essential conduits. The precision noted in earlier reports faded into vagueness. Engineering assessments that once analyzed gradients and regulator mechanisms were replaced by structural summaries concerned only with surface stability. It was as if the objective of the modernization had quietly changed. What began as an investigation into the canal foundations gradually narrowed into a reinforcement program. Exploration receded, sealing advanced. And this is where the central question emerges. If the deeper infrastructure truly belonged to documented historical periods, why was the investigation not expanded? Why were the most technically sophisticated sections not studied in detail? Why were they sealed instead? The final passages accessed beneath several major canals reportedly resisted simple classification. They were not drainage systems. They were not standard canal feeders. They were not Golden Age expansions. They were something else. Multiple surviving notes describe chambers with joints so tight a blade could not be inserted between stones. Curved passages engineered with hydraulic efficiency beyond what pre-industrial Amsterdam was expected to possess. Conduits extending beyond excavation zones, disappearing beneath districts never formally surveyed at depth. These findings did not provoke public debate. They did not reshape textbooks. They did not trigger expanded excavation budgets. They were covered. If this infrastructure predated the Golden Age, what did that imply? What if Amsterdam did not build the foundation, but inherited it? That possibility does not accuse. It does not accuse Dutch engineers of ignorance or deception. On the contrary, it suggests adaptation, remarkable adaptation. It suggests that 17th century canal builders may have encountered a subsurface system and integrated it with extraordinary skill. But if modernization revealed a hydraulic grid already present, already aligned, already optimized, then the celebrated canal rings become something slightly different. What if modernization was not construction but concealment? What if the canals were not the beginning, but the final layer? The question is not whether Amsterdam's Golden Age engineers were capable. They were. The question is whether what they encountered beneath their feet influenced what they built above. What if the true origin was older than the Golden Age, older than the medieval record, older than the timeline we were given? These are not declarations. They are structural observations. When multiple layers share identical hydraulic logic across centuries, coincidence becomes statistically strained. When pressure-rated chambers exist without documented pressure systems, the narrative requires reconsideration. When documentation grows vague, precisely where technical complexity increases, the silence becomes data. By the time dredging slowed, much of the deepest evidence had been resealed. The visible canals were reinforced. The city modernized. Steam pumps operated. Trade expanded. Above ground, Amsterdam entered industrial Europe with confidence. Below ground, the deeper layers remained largely unmapped. The modernization project is remembered as a triumph of engineering foresight. And it was. But it was also something else. A brief moment when receding water revealed a stratified system beneath a famous city. For a short period in the 1800s, workers saw walls that did not resemble their manuals, regulators that did not match their era, chambers that implied pressures no document recorded. Then those chambers were closed. If Amsterdam's canals rest upon infrastructure beyond the accepted chronology, the implications are not dramatic. They are methodological. It would mean the story of urban engineering is less linear than assumed, less about invention in isolation, more about inheritance and adaptation. And if one of Europe's most documented canal systems reveals signs of deeper integration, one question lingers. What other cities may be resting on buried systems they did not originally construct? Amsterdam may not be unique. If buried systems exist beneath its canals, similar layers may rest beneath other cities, and perhaps those layers are still waiting to be uncovered.